the original solution or OS of the given inorganic mixture, that means whatever be the salt given to you, it is first treated with dilute HCl. When all the cations of the group 1, that means a number of cations are there, mercury, lead, silver, etc., but you have to study only lead. If lead is there, it will get precipitated. Then we are going to see the scientific theory why this lead chloride is precipitated as a white precipitate. A salt gets precipitated only when the ionic product exceeds the solubility product. That is the theory. This theory is followed till the 6th group. This is the only theory. In order to explain, this is an application of solubility product. If the ionic product is greater than the solubility product, ionic product is greater than the solubility product, then the salt will get precipitated. That is the theory. When the KSP and the ionic product, if you consider, if the ionic product exceeds or greater than the KSP, then the salt will get precipitated. Fill in the blank question. In case the ionic product is less, the ionic product is less than the KSP, then the solubility less than the solubility product, the salt will not get precipitated. You have to keep in mind only these two laws. That means why the first group is precipitated means all the other elements in the second, third, fourth, fifth, everything is less solubility product. The ionic product is less. That is why. Therefore, since the solubility product on the chloride of cations of the higher groups are higher or quite high, they do not get precipitated and remain in the solution. Only one point to keep in your mind. Whatever the group that you are doing, if you are getting a precipitate, means the ionic product exceeds the solubility product. If you are not getting a precipitate, means that group you are not getting any precipitate, means that group basic radical is absent. That means only based on the precipitate color and the precipitate you can identify the basic radical. The cations of the group 2 are precipitated in the form of their sulfide. The second group, it is precipitated as sulfide. First group, it is precipitated as chlorides. The sulfides in the presence of dilute HCl. That means without the presence of dilute HCl, that means the medium should be acidic. Then only it can be precipitated. The sulfides of group 2 possess very low solubility product. That is the reason. And it can be precipitated even with the low concentration of H2 minus. On the other hand, the sulfides of group 4, that is manganese, zinc, nickel, cobalt, are possessing high solubility product. Therefore, that high solubility product, they will not precipitate here. Then, and why it is appearing? That means it is a common ion effect. That means H2S ionizes as H2S and H2 minus. HCl forms an common ion effect and reduces the concentration of H2 minus. Therefore, it can form a precipitate. Due to the common ion effect, fill in the blank question. The concentration of H2 minus ion decreases. Thus, in acidic medium, only the sulfides of the cations of group 2 get precipitated. Give reason questions can be asked from each and every group. The cations of the group 3, that is aluminum, ferric, etc., are precipitated as hydroxides of NH4OH in the presence of ammonium chloride. Here also common ion effect. That is, in low concentration, this will precipitate. But in higher concentration, group 5 will be precipitated. These possess low values of solubility product as compared to group 5. Therefore, it is necessary to keep the concentration of OH minus ions low. Give reason. And otherwise, the cations of the group 5, calcium, strontium, barium, will also get precipitated. This is done by the addition of ammonium chloride. And just like here H2S and HCl, because of the common ion effect, by the addition of NH4OH, the common ion effect, NH4OH ionizes as NH4 plus and OH minus. NH4Cl ionizes as NH4 plus and Cl minus. The common ion, that is NH4 plus, is common ion. NH4 plus combines with OH minus and undissociated NH4OH is formed, reducing the concentration of OH. Therefore, the cations of the group are precipitated as sulfides by passing H2S in alkaline medium. And the sulfides of this cation possess high solubility product and requires high concentration of ions for the precipitation. The cations of the group 5 are precipitated. That means here the higher concentration is required in the case of sulfides to be precipitated in fourth group. But in the second group also sulfide ions, but only low concentration is required. That is the difference. The cations of group 5 are precipitated as carbonates by the addition of ammonium carbonate in the presence of NH4Cl and NH4OH. That means here also common ion effect, ammonium carbonate, ammonium chloride. The common ion NH4 plus combines with carbonate ion and form undissociated ammonium carbonate. That means reduces the concentration. The solubility product of calcium, strontium, barium are lower compared to the sixth group of magnesium. That is why the magnesium will never get precipitated in fifth group, because its solubility product is compared to the fourth one, it is less. Therefore, finally we can represent, that means ionic product should exceed. Therefore, finally Mg2 plus, that is in group 6, is precipitated in the form of hydrogen phosphate by the addition of disodium hydrogen phosphate. In short, for your qualitative analysis from 1 to 6, follow the solubility product principle. When the solubility product and the ionic product comparison, when the ionic product exceeds the solubility product, the salt will precipitate. When the KSP is very high and the ionic product is less, there is no precipitation in any group. That completes our portion of theory, all the chapters. Now we can do the revision.